All right, so today this is the midterm mineral and rock identification test. You can use your old labs, your worksheets. I definitely hope you use those out of the workbook. I hope you've marked them up quite well. If we had it in lecture, in lab, you would concede on the test. If there's something I did not cover, it will not be on this test. So the test layout is just like the pre-test. I have 10 mineral samples, 10 igneous rock samples, 10 sedimentary rock samples, and 10 metamorphics. I'm going to give you a brief description of each one of those. You'll then go into Canvas and you'll select multiple choice of one of the 4 choices, and that'll determine your score. So this test is worth 25 points. So I'm going to start with mineral number 1. Highest specific gravity of any mineral that we have, has cubic cleavage, it is metallic. Chart number 1 of the mineral charts, you'll definitely see this. On chart number 1, very heavy specific gravity, the highest of any mineral. Mineral number 2, this has what's known as basal cleavage. Its dark color gives it its name. It is a common rock forming mineral. It flakes off like very thin sheets of a book. Very soft. You can scratch this mineral with your fingernail. And there's different varieties of this, and the varieties are named according to color. So number 2. Number 3, this is a metallic mineral. You'll see this on the metallic chart. It has a play of colors. Blue color, and that kind of gives this mineral away. Metallic, no cleavage, fractured mineral. We're going to find this on chart number 1, the metallic chart. Mineral number 4. This mineral has crystal form. It often forms cubes. It does not have cleavage. Very high specific gravity. Grayish streak, so even though it's a gold mineral, it has a grayish streak. And it often forms cubic crystals or dodecahedron type crystals. Mineral number 5 is non-metallic. It has a feature that is difficult to see in this camera, but this mineral has cleavage and it also has striations. So it has cleavage and striations. It is non-metallic, good cleavage in one direction. It can be a dark gray color with a blue play of colors, or it can be white. This is the white sample, and it does have striations. Even though the striations are really difficult to pick up with the camera, with straight lines, the striations are definitely there, but just really hard to see. The resolution of this camera will not allow, but take my word, it does have striations in it. Mineral number 6, 6120 cleavage, reacts to acid instantaneous. Chemical formula is CaCO3. It's a calcite-based mineral. It's very important in rock forming as far as limestone and marbles. Reacts to acid instantaneously. Number 7, another metallic mineral. This one is very metallic. It has a high concentration of iron, very high specific gravity, a gray streak, and the diagnostic feature, it's magnetic. A magnet will stick to this mineral. Number 8, salty taste. I should give it away right there. Likes to form cubes, very good cleavage in 3 different directions. Definitely a salty taste. Number 9. This mineral has cleavage. We often call this basal cleavage. So this is basal cleavage. Flakes off like pages in a book. So that's number 9. Very basal cleavage, very vitreous luster, very soft. Scratch it with your fingernail. And then the last of the minerals This is the decomposition of iron. So this was once magnetite, but it has weathered into this red color material due to the iron oxidation. The diagnostic feature about this mineral is two things. One, it could be on the metallic chart and the non-metallic chart. This one is definitely non-metallic. It has weathered to the point where it's on its way to clay. But the thing that gives this mineral away is it has a red-brown streak. So look for the mineral with a red-brown streak, and that's what it is. And that ends the minerals. We're now going to move over to igneous rocks. And so the first igneous rock is number 11. This texture is vesicular. So this is vesicular. It has holes in it, air holes. It's called vesicular. And it is mafic. So it's a mafic rock and it's vesicular. Number 12, aphanitic texture, no visible minerals. Felsic. Aphanitic texture, no visible minerals, and felsic. So basically line up aphanitic with felsic, and there's only one rock it can be. Number 13, its texture is glassy. So this is glass. It has this conchoidal fracture, this rounded fracture in it. Black color. It is felsic, even though it is black. This is 98% quartz and just a small amount of iron. So number 13 is a felsic rock, but its texture is glassy. It's often listed as intermediate, but people mistakenly call it mafic because it's a black color, but it's not mafic at all. It is really felsic. Moving on to number 14. Its texture is frothy. Very, very fine holes in it. This rock floats on water. It is felsic. So frothy texture, felsic rock. So line up felsic with frothy texture, and you'll have the name of the rock. Number 15, this texture is porphyritic. All the minerals are the same size, except for there's a larger phenocryst of potassium feldspar. This rock is felsic, contains quartz, it contains biotite, and it has potassium feldspar, the phenocryst. Felsic rock, porphyritic texture. Number 16, this is kind of a borderline with texture. Kind of an aphanitic, phaneritic. It's really hard to see the individual grain size. You can on some parts you can see it, in other parts you really can't. But this texture is mostly a phaneritic. It could also be aphanitic. But what gives this rock away, it's ultramafic because of the green color. Again, my camera doesn't pick up this green color as well as I would like, but this is ultramafic phaneritic texture. Number 16. Number 17, another felsic rock. This top part here has been polished. The texture of this rock is porphyritic. This is the potassium feldspar. This is the white version of K-spar, forming the phenocryst. The black stuff is mica. The clear material is quartz. This texture is porphyritic, and its composition is very felsic, extremely felsic. Number 18, it kind of has an aphanitic ground mass, but it has a very large mineral that stands out, a phenocryst of amphipole or hornblende. So this is a mafic rock, porphyritic texture with an aphanitic background. And so that's igneous rock number 18. Number 19, mafic rock. Phaneritic texture, so you can actually see the visible minerals. And again, since this rock is so dark, it's really difficult to see the individual minerals, but they're there. And some light you can see it better. So this is going to be phaneritic texture, mafic. Very iron-rich rock. And then igneous rock number 20 is intermediate composition. So this is halfway between mafic and felsic. Consists of two minerals, plagioclase, the white mineral, amphibole/hornblende, the black mineral, phaneritic texture, intermediate. So line up intermediate with phaneritic, boom, you have the right rock. So moving on to the sedimentary rocks. We've seen this one before. It's such a cool rock, that's why I like to use it. Number 21. This is a chemical rock. So it's going to be on chart number 2 of the sedimentaries. It is comprised of broken seashell fragments, all cemented back together. Chemical rock reacts to hydrochloric acid. I did not put the sign there, but here. Does react to hydrochloric acid. And it's on the chemical chart. Broken seashells. All right, number 22. This is a classic rock. Chart number 1. Grain size is going to be gravel. Gravel size, rounded gravels. Classic rock with rounded gravels, gravel size. That's number 22. Number 23 is on chart number 1. It's a classic rock. It's layered. Clay-sized minerals. Hard to see the grain size in clay-sized minerals, but it's got a layering to it which is called fissile bedding. It is on the classic chart, and that is number 23. Number 24, another rock that reacts to hydrochloric acid, therefore it's going to be a chemical rock. This reacts to acid instantly. Its chemical composition is calcite, and it has marine fossils in it. Very distinctive tortilla in there. Reacts instantly to hydrochloric acid because of the calcite composition. Another one that reacts to acid instantaneously is this one here, number 25. You loved this as a kid. Very soft, writes on surfaces like sidewalks. Microscopic fossils in there, diatoms and things like that. White color, very soft. You can scratch it with your fingernail. That's how soft this rock is. Number 26. This is a classic rock. It has fragments that are gravel size, that are cemented together, and these gravel size fragments are angular, so you can definitely see they're angular. So number 26. Classic rock, gravel size, chart number 1, angular fragments of gravel. Number 27, I would classify this sand size, poorly sorted. This is dirty variety of these rocks. This has some clay, it has larger fragments in it. Its gray color has to do with the name. So it is a sandstone with a gray color. So we give it a special name. It's a dirty sandstone, not wind-blowing. We find these types of rocks forming in submarine canyons offshore. And the gray color is really important in the name. So this is sand-sized material, chart number 1, classic rock. Number 28, the only true biochemical rock. This rock consists of organic carbon, layering to it. It can burn real easily. So a lot of organic material made up this rock. And then number 29, there are 3 of these, 3 different varieties. And so this is the dark variety. This is one of the rocks that make up petrified wood. And basically, its hardness is of a 7, so its chemical composition is quartz. It's a chemical rock. And quartz is the one thing that gives it away. We name these 3 different quartz minerals based on color. So there are 3 different colors. This is the black variety, there's a gray variety, and there's a red. And then number 30, a repeat in the sedimentary, but it's very important that we see these rocks, because these are probably really important rocks. This rock definitely has layering to it, called fissile bedding. If this were to become metamorphosed, it's going to create foliation in metamorphic rocks. So this is on a classic rock. This is going to be on chart number 1. Clay-sized minerals, fissile bedding, and that ends the sedimentary rocks. So we're going to move over to metamorphic rocks. And so number 31 is a foliated rock. So remember, in metamorphic rocks there's 2 textures, foliated and non-foliated. This is definitely foliated because it has these layers of amphibole and potassium feldspar. So the pink is K-spar, the black is amphibole. Foliated rock, very high degree of metamorphism. Number 32 is a non-foliated rock. It consists of gravel fragments that have been fused together. Its parent rock was either a conglomerate or a breccia. And this is a non-foliated rock. Number 33 is foliated. It has layers of mica minerals, so the composition of this rock is muscovite and biotite. Foliated. And the muscovite and the biotite will give this rock away with its great foliation. Number 34 is also a foliated rock, but this is low-grade metamorphism. This is a layered rock. Dull texture to it, no visible minerals. So very dull texture, low-grade metamorphism, foliated rock. Number 35 is very similar, but this rock has a little bit of a shine to it. And we're trying to get in the right light here. We can actually see this has a slight viscous luster to it. This is where quartz and muscovite are trying to come out of this rock real badly. So this is a foliated rock, but it definitely has not just clay minerals in it, it also has muscovite and quartz. So muscovite is really important in this rock. Rock number 36 is foliated also. We've seen this one before. This is comprised entirely of amphibole minerals. Its parent was either a basalt or a gabbro. Its foliation is in the schist family, but we don't call it a schist. We name it for the mineral that makes up this rock. Number 37, a non-foliated rock. Chemical composition is calcite, plain and simple calcite. Its parent was a limestone. It reacts instantly to hydrochloric acid. Comes in a variety of colors. Will not scratch glass. Number 38. Similar texture as 37, but this rock is very hard. It is comprised of quartz. So its metamorphic composition is quartz. It's non-foliated, and it's comprised of quartz. And quartz is the main part of its name. Number 39, the color gives this rock away as far as its name. This is non-foliated, even though it is considered to be in the foliated family. It is part of the schist family. This rock has chlorite in it. That's what gives it this green color. The little red specks you see in there, those are garnets. This is a green rock with garnets and chlorite. So it has chlorite mica and garnet. So find that on the chart. Green color. We don't call it a schist though, even though it's in the schist family. We name it for its color. And so we're going to call it according to this color, and it's not foliated. Texture, so we don't call it foliation, it's not part of it, so we don't call this green schist. We call it green something else. So that should be pretty apparent in the chart. And our last one, pretty simple, straightforward. This is a non-foliated rock. Its metamorphic composition is carbon. This rock will burn. Very shiny, black, vitreous luster, comprised of carbon. So that ends the metamorphic, and therefore the rock and mineral identification. So go on the canvas,